Hey, what's up guys? My name is the Cherno. Welcome back to my game engine series. So last time we talked about something really exciting, how to build a 2D renderer. Check out that video if you haven't already, it'll be linked up there. We've just begun this amazing journey. It's going to be so much fun. But what I thought that we would do is kind of take a look at the code we've got now and strip out all the good parts from it, specifically the stuff in Sandbox, obviously is what I'm talking about, not just the general engine, because most of it, of course, is good code. But specifically the stuff that's in Sandbox, we want to strip that out, maybe put some of it into classes, and we kind of want to eventually have a clean slate from which we can start preparing like a 2D sandbox. And then that's gonna kind of be where we test everything, and could even be the place where we actually make a 2D game from the stuff that we actually build up in this series. So today we're gonna be talking about camera controllers. At the moment, what we've got to do with specifically like with cameras is we just have a bunch of stuff in our onUpdate function, and I think that's about it. And that's just the stuff that controls a camera. And we've got this orthographic camera class, which contains a projection matrix that we make, an orthographic projection matrix. And then we just have some loose kind of code around that to actually set the position and rotation. That's fine, but I don't want to be manipulating the camera in this kind of example layer class. That's obviously very temporary. What I want to do is actually create an orthographic camera controller in the engine code base that you can use to actually control an orthographic camera. And this isn't necessarily something that you would use in a game, because most likely it's not going to behave exactly like you want a camera to behave. Like if you're making like a 2D platformer or a top-down game, you probably want the camera to behave in a certain way, and it's very likely that, you know, a camera is something that is so much kind of client code, so much like game side code, because the behavior of it is so intrinsic to the actual game that you're building, that in real games, you know, you would build the camera as a Lua script, or as some kind of script that's part of like your actual, like an entity in your scene. That would be the camera. You wouldn't just kind of use a camera that the engine comes with. However, when you're first starting out and you want a basic camera, kind of like what Unity would have in their level editor for 2D or for 3D, you know, you need that. An engine should be able to provide that for you so that you don't have to be like, okay, cool, I've started a new project in Hazel. I'm gonna have to just do a bunch of camera scripting before I can even see anything on the screen. Like that's not something that we want. So we need to kind of bring that code out. We're gonna add stuff like zooming in and out, and a bunch of other stuff probably to the actual camera class. Well, we'll create a new kind of camera controller class, and we'll talk about that, just so that we don't have to deal with all this code inside Sandbox. Before we begin, just want to thank all the patrons who made this series possible. Patreon.com/the Cherno is the best way to support this series and everything that I do here on YouTube. You'll get a lot of really cool stuff in the Hazel development branch. I actually pushed like three commits, like I think today, into that development branch that was to do with 2D stuff. I'm going to actually merge a bunch of the 2D stuff that I've done ahead of time into that Hazel development branch, because of course in the future 2D and 3D are going to have to play nice. So if you guys want to jump ahead in both 2D and 3D and see what Hazel is capable of and what we're building towards, then help support the series and you will get access to that code. Okay. I'm not going to do too much talking. We're actually going to jump in and do some code here, because there's not too much to talk about. We're basically going to make a class called Orthographic Camera Controller. It's basically going to be a wrapper around a camera, an orthographic camera, which is a class that we already have. And it's going to add some extra stuff to actually control that. It's going to have like an onUpdate function where we can actually process key events, and it's also going to have onEvent. And that'll be able to handle stuff like window resizing, as well as mouse scrolling and stuff like that, so that we can zoom in and out. So let's jump in and take a look at the code. Okay, so scrolling through this code, we have a bunch of stuff inside our onUpdate function. This is sandbox_app.cpp. You can see this is all inside example layer. This is this file also has our sandbox application. This was kind of the first thing we started off with in Hazel, and it's great. And it's a nice little sandbox, because you want to have a sandbox just to run random code in, but we also want to actually have we also want to have like an actual 2D sandbox that we can play around in, so that as we're developing our 2D renderer, we can have like a scene set up or something like that, and we can actually have an example of how to make a 2D game without, you know, all of this kind of boilerplate code that we don't particularly need. So that's what we're going to do today. We're going to start cleaning this up, and in the future, in the next few episodes, I probably will have like a dedicated maintenance episode to just clean up a bunch of stuff, because obviously we kind of accumulate more and more tech debt the longer we write code, and I'm kind of putting off fixing all of that episode to episode just because I want to get these concepts across and kind of be more effective, I guess, in my teaching style, rather than actually cleaning up irrelevant code like as I come across it, which is something I would do in the real world if I was actually programming and I'm kind of going through this code and I see something that I don't like. I might fix it just immediately, then and there. That's kind of a good way to go. But with this, of course, I don't want to randomly be distracting myself, being like, oh, actually, you know what, we should fix this. So I will have a dedicated maintenance episode in maybe not the next episode, but the episode after. So just a fair warning. If you're expecting something exciting, then there's going to be a maintenance episode soon. All right, cameras. So let's take a look at this orthographic camera class. So it's really simple, as you can see. It's really just a bunch of matrices and then some very, very basic code around that. Everything has to be set inside this actual class. I mean, it's got its own, it does keep track of its own position and rotation. It's not literally just a projection and a view matrix. And in that way, you know, you have to set everything manually from the kind of outside of this class. No, it does have that stuff and that's great, but we want to actually take it a step further and add input to this class. Now, I don't want to do this, right? This is just data. It's pure data, it's pure maths. We don't want this to have anything to do with input. We don't want to tie it like that at all, because what this is and what this represents, and in fact, I'd probably be inclined to even get rid of position and all that stuff from this class, because what this should be is a representation of an orthographic camera, which is really just a representation of a projection matrix and a view matrix, these two, right? Or together a view projection matrix. This is what it is, and this is why it exists. We want to send this data to the renderer. That is all that this is. Anything extra is stuff that we add to make controlling this data a little bit easier. But ultimately, we need this to exist because we need to be able to get this data to our shader so that we can multiply these matrices with our vertex positions and with our actual object transforms if need be, to actually position vertices on our screen inside our display area, inside our rendering area correctly. That's what this is for. So we don't want to start adding extra stuff to this, because the more we add to this class, the bigger it will be, the more data it will contain, the more bandwidth it's going to occupy in our render submission queue when we actually get around to that. There's a lot of implications that we don't want to deal with, and that we don't have to deal with if we just kind of make an extra class that goes on top of this class, basically, and then that will be our controller class. Because obviously, you know, we do need to submit orthographic camera to the renderer, but the controller should go nowhere near the renderer, because it's just a user interaction little module that basically will manipulate this data. So hopefully that makes sense. That's kind of what we're building. And so because of that, what I could do is just make another class right here, call it like orthographic camera controller, or ortho camera controller, but I like to be pretty specific with my class names. We could do this, but I don't want to do this in this file. The reason being that we need a bunch of stuff for this. We need events, we need input, we need basically a whole bunch of stuff that will basically have to be included, but I don't want to do that stuff here because, again, we're trying to keep this kind of lightweight and I don't want to fill this file with includes. So what we'll do instead, I'll just copy this. What we'll do instead is make a new file alongside this file. So, and we'll just call it, so in the renderer, we'll make a file, and we might move this out in the future because, again, it's not really part of the renderer. In fact, I don't really want to put it there now. We're just going to dump it in Hazel. In the maintenance episode, we'll go through some of these things and we'll move them to core, or we'll move them to anything else that where they might belong. Because yes, this is getting cluttered, and Hazel Dev doesn't look like this at all. So something to take note of. But anyway, I'll put it in here for now. I don't really want it to be part of the renderer because it's really not part of the renderer. And then what we'll do here is make namespace Hazel. We'll make that class called orthographic camera controller. And then what that will be is basically, as I said, a wrapper around orthographic camera. So we'll have that orthographic camera, and we'll have a whole bunch of other things here as well. So when we create an orthographic camera controller, the way this is going to work is it's basically going to be a viewport into our actual view that we have here. So really the only thing we need for that is to determine what kind of projection, I'll say units we want to deal with. So whether we want it to be per pixel or something a little bit more abstract, I'm going to go with something a bit more abstract. I don't want this to be per pixel. Per pixel meaning we would literally set left and right to 0 and like 1280 respectively, so that when we use 1 unit in this camera, it's 1 pixel. Not going to do anything like that because we don't really need to, and it's going to make other things harder. What I'm going to end up doing is basically just setting this to, by default, probably have a zoom level of 1. And if we have a zoom level of 1, that's basically going to be what our y-axis is going to be like. So vertically, by default, when this camera starts up, I want there to be 2 units of space, no matter what the screen resolution is, really. And then horizontally, we'll basically have to multiply our aspect ratio by those 2 units so that we get the correct aspect ratio horizontally. And then by zooming in and out, we'll simply adjust this accordingly. So that basically if we zoom in, we obviously widen the area. Sorry, if we zoom out, we widen the area so that more is in view. And if we zoom in, we're effectively just increasing or decreasing the space that we have in this actual projection matrix, in the orthographic projection matrix, so that we basically cover less area and thus everything will be bigger. So you'll kind of see this in action and it will make more sense, I think. So what we'll do is we'll actually take in a width and height. Now, this is just going to be used to calculate an aspect ratio. We could even just take in an aspect ratio as a single float. Width and height, yeah, in fact, I think we will do that just because this might be a little bit confusing, because ultimately it's not going to matter if we put in 16, 9, literally 16 and 9 for width and height, or 12, 80, 720. It's ultimately going to be the same. That might confuse people. We're just going to take in an aspect ratio. Okay, so we'll store that aspect ratio, and then the other thing I want to store is an actual zoom level. So our zoom level will set to 1 to begin with. Note that I'm creating this stuff before the orthographic camera. That's important because we're going to use this stuff to initialize the orthographic camera, and the order of initialization is the order in which these variables are actually, these member variables are declared in. So make sure that you don't try and do anything like this, because if you try and do that, even if you do initialize it first in the constructor, this will be initialized before these, which means that this will be uninitialized memory because they haven't been initialized yet. So make sure that you initialize these 2 first. Okay, cool. So we'll have that. Other things we need is an onUpdate function with a time step, of course. See, this is what I mean. Like, you know, we need to include time step now, not something that orthographic camera needs at all, because it's just a bunch of data. It's just a bunch of maths. Why on earth would it need a time step? So we'll just do renderer / orthographic camera, and then we'll include our time step. We'll also include events. So we'll do events / we are in here. I'll just do Hazel / I really don't like doing, because we might move this file in the future, so I really don't like doing relative paths, because everything, since we are here, we could just do renderer / event /, but it's better to do Hazel / everything that we kind of need, because that way, if and when we move this file, everything will still work and we won't have to refactor everything. Okay, so Hazel events event.h. We'll need 2 specific types of events. In fact, we probably don't need this here at all. Application event and mouse event. So mouse for like scrolling, and application for the window resize that I talked about. Okay, so void on update, void on event, event p. And then private functions we'll have is the stuff that I mentioned for scrolling. So this will be bool on mouse scrolled. Let's see, mouse scrolled event p. And then on window resized. This will be a window resize event. Okay, cool. So we've got these events now. That's great. I'm just trying to think. I think that's, I mean, we'll probably want other stuff as well, but for now that should be enough to get us started. So if we pop over to the CPP file, I will include the precompiled header, and then I will also include orthographic camera, of course, .h, orthographic camera.h, namespace Hazel, and now we can just use Visual Assist to create everything for us. There we go. Okay, cool. So let's take a look at what we currently had, sorry, this is camera controller. And we can basically copy and paste a whole bunch of code from here. So if we look at what we had here, this was our onUpdate function as far as the camera was concerned. And then you'll see we also did a set position and set rotation. So what we'll do is move that to onUpdate. We still need this stuff to be in the onUpdate function. What we don't need is, well, the mouse scrolling and window resizing are going to be events, but this stuff still needs to be as actual like onUpdate kind of loop things. Otherwise it won't be smooth. The scrolling doesn't have to be smooth because our mouse wheel is not smooth, it's in increments usually. So because of that, it's fine to use an event for it, but otherwise you could also implement the mouse scrolling, for example, in here. You could implement window resize in here. You don't need to do them as events, but we will because that's a little bit better. Okay, cool. So we'll do input for all this stuff. We are inside Hazel, so we don't need to do the Hazel namespace at all. I'll just get rid of this stuff. I'm actually going to change the keys that we chose here. The reason being that, you know, left, right, up, down, that might be more of like a character controller thing. At the moment, the way that my hand rests, obviously, it would be better to use WASD for the camera just because we wouldn't have to deal with moving my hand all the way over to the right side of the keyboard to access those arrow keys. I think everyone would probably prefer WASD. So we'll just change all of these to WASD, and then for rotation, which I will make optional, by the way, I'll just make Q and E rotation. And in fact, what I'll do is I'll add a rotation boolean over here into the constructor. So this will be false by default because I don't think camera rotation is that useful for 2D. But if you want, you know, you'll be able to turn it on and use it. So we'll kind of leave it up to whoever creates this class to decide. So we don't need to initialize that here. Okay, cool. And then we'll set rotation here. So let's talk about our constructor. We need to basically create the camera. So the camera is going to be basically the left side of the camera is going to be the aspect ratio, or the negative aspect ratio, multiplied with the current zoom level, which will be 1 by default. So it's literally just negative aspect ratio. And then the right side will be the same but positive. And then the bottom will be basically the same, so negative zoom level, right? The same without the aspect ratio is what I mean. And then zoom level will be the top side. So basically this is effectively -1 to 1 in the vertical axis, and then negative, well, whatever our aspect ratio is, which is probably 1.78 to positive negative 1.78 to positive 1.78. So those are kind of the units we're dealing with. And then we'll also set up the rotation. So M rotation, and then rotation, okay? So this stuff we will only do if rotation is actually enabled. Otherwise, we don't have to worry about that at all. Camera rotation are variables we will probably need to track, as well as the speed. So what I'll do is we'll include input first of all. So I think that's in Hazel slash input. Is it? Yep, Hazel input.h. And then the key codes as well. So see stuff like this. This is exactly why I wanted to make a separate file, because there's way too much stuff to deal with. Okay, coming back into here, let's think about what we need. So we need the camera rotation, we need the camera position. Camera rotation is just going to be a float, which we'll set equal to 0 by default. And then camera position will be a glm vec3 m camera position, and we'll set that equal to 0, 0, 0 by default here, making sure to actually initialize it this time. Okay, move speed and rotation speed I will also kind of move over here, so we will have you know, our speeds essentially. So float m, we'll say camera translation speed equals 1 maybe. We'll figure this out in a minute. And then camera rotation speed equals 1 as well. We'll see what they're like. So I'll just refactor this to be a camera translation speed. You may want this translation speed to actually be a function based on the current zoom level. So you might want to translate faster if you're zoomed further away, and then slower if you're zoomed in. But that might be something that we do in the future. Okay, cool. On event. So we basically need to steal some existing events that we've got. I'm sure we've got them somewhere. I mean, we don't necessarily need to. The reason I say that is because it's just easier to copy and paste this stuff. But we have this Hazel bind event function macro that we can use, which is really like easy to use. So So we'll use the event dispatcher. We'll basically give it the event, and then we'll dispatch based on what we deal with. So we want to obviously handle the mouse scrolled event. So mouse scrolled event, and then we just bind an event function to that. And then I think, because I have not used this in a while, we literally just give it the function. So it's just going to be orthographic camera controller on mouse scrolled. So this function here. And that should be pretty much it, I think. Now we should have mouse scrolled event already included here, so that should be fine. Hopefully that compiles. And then we'll do, unless I just completely missed something, window resize event, which is our type, and then orthographic camera controller on window resize, like that. That should be pretty good. I think that's it. It doesn't look like it wants to compile. That may just be because, no, this is inside event. Let's see, this got changed actually to be a little bit, to be not a standard function. That was a pull request that we accepted. Yeah, let's just hit F7, see what we get. See if this is related. Might just be IntelliSense. In the meantime, we'll just return false here as well, so that we don't get that. So dispatch is not a member of event. Oh yeah, okay, so I just made a stupid mistake, of course. This has to be dispatch or dispatch. Okay, cool, that looks better. So that's basically how we dispatch our events. Now we need to figure out what to do. So mouse scrolled event gives us a both a horizontal and a vertical scroll, so we'll use Y offset. What we'll do is apply, basically change the zoom level by that offset. So we'll just say zoom level minus equals get Y offset. And we'll see what that gives us. And then we have to recreate the camera. So instead of recreating the whole camera, I'm going to add a function called void set projection. This will basically do what the constructor did. So we'll grab this stuff, this code, put it in here, copy this. I'll probably put it, we'll make it the first thing, just because it's pretty important. And also it basically does what the constructor does. So we'll grab this code, put it here. This is a nice little live coding session because it's been a while, I think, since I've typed this much code and live as well. So let's see. So over here we basically have to recreate. Oh, whoa, what am I doing? This is completely wrong. Sorry, this is orthographic. Oh, did you see that? I went into, didn't I hit Alt-O? Yeah, that's weird. Anyway, I somehow got into the wrong CPP file. Never mind. I was going to say there's a lot of code in that class. And here we are trying to keep it simple. So orthographic camera set projection. So we're going to copy this and paste it here. So this is now going to be just setting up that projection matrix. And then obviously we need to reset that view projection matrix. And that's it. You could change the constructor to do this. But doing so, not as ideal, I guess, because then we'd be initializing projection matrix to its kind of default value first and then overriding it, which is not something I want to do really. So we'll keep this separated like this. But I think that's it. We shouldn't need to touch the view matrix at all because it should be already set to whatever it needs to be set to. Okay, cool. So now that we've got that, we can actually reset that. So we'll probably have to actually set a minimum for this zoom level, but we'll worry about that in a minute. We'll say camera, what is it? Camera.set projection. And then we're basically going to set it to the same thing that it was set to in the constructor. So we'll grab this all the way over here. Now the zoom level has changed, of course, so we'll recompute everything. So basically the idea is mouse scrolled is changing the zoom level, whereas window resize is changing the aspect ratio. So we're basically modifying those two values. So in the window resize, aspect ratio is going to equal e.getWidth divided by e.getHeight. And these, I think, are integers. So we need to make sure that we actually cast them to float. Otherwise, we will get 0 probably, or 1 or something like that. Okay, cool. So there we go. Recreating everything. That should be okay. I'm not actually sure if this branch of Hazel supports window resizing. So that will be fun to see. If not, we'll have an episode on that soon. Okay. That's looking pretty good to me, actually. So we need to set the camera position. We're not doing that. So camera position, mCamera.set position to mCamera position. And then if we have rotation enabled, I guess we'll also set rotation. So camera.set rotation to mCamera camera rotation. All right, so that's it. This is our camera controller. You can see that basically all it is just a way to set all of the different values we have inside our camera class. Now, if we go back to Sandbox app, we can strip the rest of this code out. So we don't need anything to do with camera at all. In fact, we can just remove the camera. If I scroll down over here, I will change orthographic camera to orthographic camera controller and just make, I'll just call it M camera controller. This will be something that I guess we will need to include inside Hazel. So we have orthographic camera, we'll have, that's part of the renderer, whereas I guess what I'll do is maybe over here, we'll include just the orthographic camera controller. Okay, so now we have this set up. This should be okay. Let's see where else we got rid of camera. So begin scene still needs camera, of course. So we'll do camera controller.getCamera, and I will add that function. If we go back to orthographic camera, we will, sorry, camera controller, which doesn't show up here. Great. Okay, here we are, and we'll just do a orthographic camera reference get camera return M camera, and then I guess I'll also provide a const version just in case we need it. Okay, cool. So we have a const and a non-const version of get camera. All right, so that should be it. This is still sad, namespace Hazel. Okay, let's just try and build this and see what happens. If it still doesn't work. Okay, so there's no such file or directory. Okay, I don't have show all files selected. That's probably why. So if I come back here, you can see I accidentally added it. Make sure you use this show all files thing in Visual Studio, because if you don't, it will just make stuff at the root of your project directory. So if I actually put this into Hazel now, and everything else, by the way, compiled because we used absolute paths, not relative paths. So in other words, we used relative paths to the actual Hazel directory, which was a compiler include directory. So everything worked there, but of course in Sandbox nothing worked. So we'll just recompile that code. Okay, so no appropriate default constructor for camera control. Okay, yeah, so this is gone now. And we need to initialize camera controller instead. M camera controller. So this is just the aspect ratio, which again, you could just kind of, we know that we're dealing with like a 16:9 thing. We're making our window at 1280 by 720. So what you could do is literally just work it out by doing something like this. Really simple, you could feed in width divided by height here. You could put in 1.7778 or whatever you want to do here if you know that it's 16:9, but we'll just keep it simple. 1280 by 720, that is what our width and height is. So we'll set that as our aspect ratio. I think that's it. Camera position and all that stuff can also go. So we'll kind of clean this class up a little bit. Camera rotation speed. So what did rotation speed was actually 180. Okay, I set it to like 1. So that should be fun. And move speed was 5. So we'll kind of remember that just in case we need to set our camera values appropriately. If I just run this program, now that we know that it compiles, hopefully we'll get something actually rendering on the screen, and maybe we'll even be able to move our camera and do all that fun stuff. Okay, so we get a blank screen, and we just don't see anything at all. So let's take a look at why that might be happening. Oh, well, actually, I just realized I'm not calling any of the functions we made at all. So obviously it's not enough to just make a camera controller, you actually have to hook into the methods that you need. So basically on update, we should be doing camera controller on update with the time step. So this will kind of be our update, and this will kind of be our render. They're combined into one function because there really is no render function on the game thread, on the kind of application thread. What we do is something called a render submission, which does happen on update. And then the render thread will actually evaluate that render queue in the future. So I think I had a question about this a while ago. Yes, there's deliberately just on update, because in any implementation, if you had on render, it would just be called like immediately after on update or whatever. There's no point dividing it into two functions and just, making the code base more complicated than it needs to be. Okay, cool. So there's the on update, and then we also need on event. So over here, we'll just do camera controller.onEvent. And I'll actually just call it E, because some weird syntax highlighting occurs, because I think, well, event is a C# keyword, but apparently it sometimes gets used in C++ as well. Not really sure, but Visual Studio likes highlighting it. Anyway, okay, cool. Still nothing. We should be seeing stuff even if we didn't have this update stuff, so that's not that far-fetched. So let's see what happens here. So camera controller we set to 1280 divided by 720, which is of course our aspect ratio. Rotation is false by default. We set camera to negative aspect ratio times zoom level, which I'm sure is 1. Okay, aspect ratio gets initialized first, does it? No, it doesn't. Aspect ratio doesn't get initialized at all. So aspect ratio should be set to aspect ratio, like that. In fact, we probably don't need aspect ratio because we redo it here. We're still storing it, but that's fine. Just make sure that you're actually initializing it. Let's hit F5 again. Another way to debug that, apart from just reading the code, would have been to just put a breakpoint in and see that aspect ratio wouldn't have been a proper value. Okay, so WASD moves everything. Mouse wheel, as you can see, scroll everything to the point where we go upside down, which is fun. And then Q and E do nothing, but if I recreate this with rotation set to true by just adding another parameter over here in our camera controller initializer, then Q and E should in fact rotate our view. So let's take a look at that once it compiles and launches, and here we go. Okay, Q and E do in fact work. They're very slow as predicted, because it did used to be 180. That used to be the speed, now it's 1. So maybe let's set the speed to 180. Would be great to have an actual getter and setter for that, but we can add that as needed. By the way, that is our rotation speed here. Translation speed, like 5 maybe? Not sure. As I said, it's probably nice to have it as a function. And in fact, I might make an episode just talking about this stuff, because you could add like a curve to that rotation based on the zoom level. Sorry, not to the rotation, but to the actual translation speed based on the zoom level, so that you wouldn't have to deal with that. Also, the zoom feels a little bit. I'll actually multiply that by 0.5. A little bit too quick, I think. So we'll just multiply that by 0.5. We also want to make sure that our zoom level is never less than, so basically we'll just clamp it. We'll say that if the zoom level, we'll select whichever is max. So we'll do zoom level or 0.25. So basically we won't go below 0.25. That should be about good, so that we don't actually kind of go too far in. You can see we can't go any further than that. Otherwise, looks pretty good to me. I would probably actually make this 0.25 because it does feel a little bit too fast, the zooming. You could have a zoom speed as well if you wanted to, but I think we're probably okay. And yeah, you can see when we're in, we move kind of way too fast, I think, and when we're out, it feels like we move too slow. So to fix that, what you could do, technically speaking, and I probably will talk about that in a dedicated episode just because it's quite fun to play around with curves and stuff like that. But basically what you could say is that this, camera translation speed that we set could basically be equivalent to our zoom level, our current zoom level. So if you do something like this, and zoom level, by the way, the higher zoom level is, the further out you're zoomed in. So that makes sense. So you can see when we're zoomed in, we move nice and slow, but then when we zoom out, we move nice and fast, which is good. In fact, a linear curve like this looks pretty good, so we might keep it as that. For now, that looks pretty good to me. But we'll talk more about functions and stuff like that in the next episode probably. So there we go, we've got rotation, we've got movement, which is pretty cool. If we go back, we'll just disable rotation because I don't think we need that. We haven't tested resizing. So I'll just do that now quickly. If we boot this up. Okay, cool. So if I resize the window, then our camera will hopefully resize. But you can see that I don't think we support resizing at all properly. So, because this viewport you can see gets cut off up here. So we definitely need to talk about resizing in the future, maybe next episode or the episode after. But other than that, there we go. There's our camera controller. It's super simple. It's a class that's literally just designed to be a camera controller. I think everything else is pretty good. You could clamp the out zoom level as well, and you can use STD clamp or STD min as well as max to actually make sure that you don't zoom too far out. But I think that's fine. I think the big problem is zooming in too far, because then you basically wind up with flipping your view upside down. But anyway, that's it. Hope you guys enjoyed this episode. Please hit the like button if you did. As mentioned earlier, you can also help support the series by going to patreon.com/thecherno. Huge thank you to everyone who does. help support this. Yeah, I mean, that's a camera controller. It's really cool to kind of take this out into its own class and tweak it as long as you need to get this to be like the perfect camera controller. Next time, as I mentioned, we might take a look at I did want to actually make an episode talking about like mathematical curves that we can apply to certain properties. So instead of having like a boring camera translation speed, which is what we had now, you can see that we basically set it to be the zoom level. So actually realizing how that works, I think, is very important. Not to mention that instead of having it linear like it currently is, it might be nice to have like an exponential curve or something like that. So it might be something that I talk about next episode, we'll see. Other than that, we also need to fix window resizing, and then we need to have a maintenance episode. So I might, depending on how much stuff we end up having for the maintenance episode, I might make window resizing part of that. But I think window resizing is probably a decent topic in itself to have in its own video. So that's the stuff that's coming in the future. Yeah, thank you guys for watching, and I'll see you in the next episode. Goodbye.